All right, let's jump right in. What if I told you an AI could spot the key signs of Alzheimer's disease years before you'd ever notice a symptom? And get this, what if it could do it using just the common, everyday medical data that's already in your file? Well, in this explainer, we're going to break down a really groundbreaking study that does exactly that. This could be a total game changer in the fight against this disease.
So here's the massive challenge we're up against. The changes that lead to Alzheimer's. They start building up in the brain up to 20 years before someone even feels like their memory is slipping. 20 years! Finding the disease during this silent phase, that's the holy grail for doctors and scientists. But man, is it tough. So the big question is, how do you find something that's hiding in plain sight for so long?
And here's the thing. It's not that we can't see the disease. We can. The problem is that how we see it creates this enormous bottleneck, a traffic jam really, for everyone involved, patients, researchers, you name it.
Okay, so to really get why there's a bottleneck, we gotta know what we're even looking for. Biologically, Alzheimer's boils down to two main culprits, two bad guys in the brain. First, you've got these things called amyloid beta plaques. Think of them like sticky gunk that builds up between your brain cells. Then you have tau tangles, which are like twisted up wires that form inside the cells. Finding these two is the key to knowing for sure if someone has Alzheimer's.
And this is where we hit the big dilemma. The gold standard for spotting that gunk and those tangles, it's something called a PET scan. And yeah, it's super accurate, but it's also crazy expensive. You can only get them at special hospitals, and frankly, it's a huge hassle for the patient. Now, on the other side, you've got all this standard medical data. You know, your regular MRIs, blood tests, memory quizzes, that stuff is cheap, it's everywhere, it's routine. The problem? The trade-off has always been accuracy. You just couldn't be as certain.
So, what does this all mean? Well, this total reliance on pricey PET scans creates this massive logjam. It makes finding the right people for clinical trials way harder and more expensive. And that, in turn, slows down the hunt for new drugs and even limits who can get their hands on the therapies we do have. It's a real problem.
But what if you didn't have to choose? What if you could get the best of both worlds? Imagine using all that cheap, easy-to-get data to predict with high accuracy what one of those expensive PET scans would show. Well, let's introduce the hero of our story, a new AI model designed to do exactly that.
Yeah, the best way to think about this AI is like a digital detective. It's like Sherlock Holmes for your brain. It doesn't need to be at the crime scene, the actual PET scan, to solve the case. Instead, it's been trained to sift through all these different clues from a patient's regular medical file and figure out, okay, based on all this, what would a PET scan find?
So what kind of clues are we talking about here? Well, it's all the stuff that doctors collect anyway. You know, basic info like your age, your medical history, how you do on those memory tests, certain genetic markers, and even a standard MRI scan. But here's the really cool part, the part that makes this so practical for the real world. The AI is smart enough to work even if some of that info is missing. And that's a huge deal, because let's be real, patient files are almost never perfect.
All right, so just how good is this digital detective? Well, like any good investigator, it's only as good as the clues it has to work with. So let's see what happens as we start feeding it more and more evidence.
So if we give the AI just the bare minimum, we're talking just basic demographics and patient history, its predictions are, well, they're not great. Honestly, it's just a little bit better than flipping a coin for both amyloid and tau. So it's a start, but our detective definitely needs more to go on.
But then, watch what happens when we hand our detective just one more piece of the puzzle. A simple structural MRI scan. Boom. The accuracy jumps way up. It gets a lot better at predicting amyloid, and just look at that huge leap for predicting tau. This tells us that those physical changes in the brain structure, the stuff a regular MRI can see, are a super powerful clue.
And finally, what happens when we give our detective the full case file? We're talking the MRI, the cognitive scores, the genetics, the whole shebang. Well, that's when it reaches its absolute peak performance. By piecing together all these different kinds of clues, the model turns into a seriously powerful predictive machine.
Okay, so we've seen how it learns, how it gets smarter with more clues. But what about the final exam? Let's take a look at the AI's official report card. And this is based on how it performed on data it had never ever seen before. All right, this really is the moment of truth. When it came down to it, how well did the AI's predictions actually line up with the real-world PET scan results from thousands of people? Okay, for predicting those sticky amyloid plaques, the model scored a 0.79. Now, in the world of AI, 1.0 is perfect, and 0.5 is basically random guessing. So a 0.79, that is a really solid score.
But check this out. For predicting the tau tangles, it did even better. It scored an impressive 0.84. And that's a really big deal because we know that the amount of tau in the brain is what's most closely tied to actual memory loss and cognitive problems.
Now, these numbers are great. They look fantastic on paper. But they're still just stats, right? The real question, the ultimate test, is do these predictions from a computer actually match up with the biological reality of what's happening inside a person's brain?
And the answer was a resounding yes. The findings here were crystal clear. The AI's predictions didn't just match the PET scans, which is what it was trained to do. They also lined up perfectly with the known biological stages of how Alzheimer's progresses. And, this is the most important part, they even matched the ultimate ground truth, what pathologists found when they examined brain tissue after death. That's the confirmation. It proves the model is seeing something real, something biologically meaningful.
Okay, so the science is incredibly cool, no doubt about it. But what does this actually mean for you, for me, for the real world? Why is this AI detective such a potential game changer?
Well, just think about this for a second. In their test group, just the people in the study, the model was so good it could have saved almost 600 people from having to go through an unnecessary PET scan. That's 600 people who wouldn't need an expensive, invasive, and let's face it, pretty stressful procedure. That is a massive real-world impact right there. And the ripple effects from that could be enormous. First, it could make finding people for clinical trials way faster and cheaper. It could also open up access to early Alzheimer's screening for people who don't live near a big fancy medical center. Plus, it helps make sure that new drugs are tested on and given to the people who are actually the right fit for them. And of course, like we just said, it just makes the whole process easier and less stressful for patients.
And here's the billion-dollar takeaway. Literally, developing a new drug for Alzheimer's costs a fortune. We're talking tens of billions of dollars, and it has a soul-crushing 95% failure rate. A huge part of that cost is just screening patients using those expensive PET scans. A tool like this AI detective could slash those costs and make the whole process way more efficient. And that could seriously accelerate the search for a cure. And that really leaves us with a pretty powerful thought. If we have an AI that can predict the biological future of a person's brain, could that be the key to creating a future without Alzheimer's at all? By seeing the signs earlier, cheaper, and more easily than ever, we're not just getting better at diagnosing, we might just be changing the entire game for how we research, treat, and maybe, just maybe, one day prevent this disease entirely.